Thanks. Hi, good afternoon, everyone, and thanks for joining us for this talk today. My name's Powrie, and my colleague Peter Knight. We both work for UK Data Science, and that is part of the digital arm of GE Aviation. And our focus is to develop analytics, advanced analytics and digital solutions for aviation customers, and that may be internal to GE or external to GE. And we've been doing this for quite a few years now, as I think you'll gather from the talk that we're giving. And we'd like to share our experiences with you, and in particular, our recent experiences of trying to port analytics, our own analytics, into PySpark ML pipelines. So a little bit about what we're going to talk about today. The focus will be GE Aviation's, and it's around commercial engines. GE Aviation does cover a lot more than that, but it's what we're doing in the commercial engine space and what we're doing with our data and our analytics. And we'll, as I say, we'll share some of our analytic journey with you. Then we'll move on to the detail, which is where we're trying to port analytics today, and Pete will talk you through that, particularly focusing on the PySpark ML pipelines conversion. And hopefully we'll have time for a few questions at the end. So a little bit about General Electric. I hope people have heard of General Electric here. Can we have a show of hands? Do we know who General Electric is? That's not bad. That's good. That's good. So, but for those of you who don't, so General Electric is a very large global company. We have over 300,000 employees worldwide. Aviation is just one business section of that, one business sector. We have other parts like healthcare. We have oil and gas, power, renewables, capital. So we have a number of different parts, but we're talking today about GE Aviation. And aviation itself has 40,000 employees. Again, it's global, it's worldwide, and we contribute quite a bit to the overall General Electric turnover. Last year, we produced over $27.4 billion in revenue, and to put that in context, 20 billion of those were from commercial engines alone. And the rest of that comes from things like systems, military engines, additive manufacturing, which is an area we're very keen to grow, and also other general aviation products. We have more than 33,000 commercial engines out in the field today. And for those of you who don't know, the commercial engines are anything from those that power the regional CityJet type aircraft all the way through to the long-haul transatlantic aircraft provided by Boeing and Airbus. And to make you think about what that really means, approximately every 2 seconds, an aircraft that's taking off is actually powered by a GE engine. And for us, what that means is we see something like 100,000 flight engine records a day from our engines that we want to look at. And that helps me then put into context how much data we're trying to deal with and where we've come from and where we see we are going. So going back to, I think that's one of them up there now, we can hear, but going back to the mid-1990s, our flight record data was typically around 30 different engine parameters and 3 snapshots per flight, so quite limited. As we've moved into the 2000s, that has grown to more like 1,000 parameters and typically 20 snapshots per flight, and that's pretty much where a lot of our engine platforms are today. But we see this growing again in the future, not necessarily more parameters, but actually we want to collect this data continuously, so not just snapshots, and that has a big impact on the amount of data that we want to collect and the amount of data that we want to analyze. So we have seen, even from the past to where we are today, an explosion of data, and we know that's going to continue. And that's clearly a message that we've seen across many talks at this conference. So just to give you an idea of the kind of things that we use our data for and the kind of applications that we do within commercial engines, and this is an example for commercial engines only. We do an awful lot more than this within GE Aviation and within the wider GE. The engine flight records data that I talked about, that's just one data source that we have. We have many other data sources, for example, things around shop visits, work orders, inspection data, all sorts of environmental data, all sorts of different things we try and use here. And what we try and do within the engine's operational life cycle, we kind of have two aspects to this. One is around time on wing, so that's where the engine's flying on the aircraft, and we want to keep that on aircraft as well as we can for our customers. Keep our customers flying is what we're thinking about. And while we're doing that, we want to give them the most effective usage out of our engines and most efficiency without compromising safety. Then we use that data to tell us how the engine's wearing, how it's being used, and we use that to help us then predict things like shop visit forecast. So when an engine's going to go into a shop and when it goes in, what kind of work we want to do on that, so what parts we might want to repair or replace. And that then feeds a material prediction, so what parts do we actually need to have in the workshop when the engine is being repaired, and that of course drives our whole supply chain management piece, which is when do we need to raise purchase orders, when do we need to chase suppliers, and so on and so forth. So there's a lot of data and analytics around that. Just to talk a little bit about time on wing as well. So the kind of things we do while the engine's flying, we have digital twin models. These are physics-based models, which we then kind of aggregate to see which components are wearing the most in the engine and therefore which can drive the shop visit or some kind of inspection that's required. Borescope imaging, we use things like computer vision to try and improve that. So borescopes, for those of you who don't know, it's kind of like an endoscope for an engine. So we have a camera at the end of a cable that we put into the engine, and we try and look at the parts without sort of taking the engine off wing or without dismantling it. And then we look to see how worn those parts are. It's really quite a tricky environment to get good images from, so we're doing a lot of work around that to try and improve that imaging capability. The other two areas is fleet management. We use clustering techniques and segmentation, where we're trying to figure out can we separate the fleet out in how it's being, in how we need to look at it. So that might be how the engines are being operated, where they're being operated, because operating an engine in the northern hemisphere in quite cool and dust-free atmosphere is not the same as operating in the desert with a lot, or hot and harsh regions where there's a lot of sand and heat. So we look at things like that. We perhaps look at what the operators are doing, and we also we may look at kind of what engine configuration or variant that we're flying. So we try to segment the fleet based on those kind of factors, and then figure out how do we need to prioritise what we look at, what we inspect, and what we maintain. And then finally, fleet monitoring, which is actually the main thing we're going to talk about today, and this is where Peter's experience is with porting analytics. So recall I was talking about the 100,000 flight records a day that we need to look at. We do analyse those on a per flight basis, and what we need to understand is there anything unusual in that data. So if you remember, there were multiple parameters coming off, and we want to have a look and see if there's anything changing in that needs our attention. Clearly, we can't do that manually. We have to do a fairly robust automated screening of that, and that is quite challenging in itself. And so basically, we also have in-house analytics that we have developed that we apply to this, and that's part of our experience today, is how have we ported those custom analytics into Spark. So I won't say too much more, but just one more slide on that in-house analytics. It's called ProDAPS. I won't go into why it's called ProDAPS, but you can ask me offline. It's just a bit of a detailed explanation to give here. So this is a custom in-house machine learning library that we have developed based on PGMs, probabilistic graphical models, and it's all based on very sound statistical theory. So we developed this rather than using things that are available third party, because we had real challenges with aviation data. It's multiple parameters, it's quite noisy, it's often at least bimodal, if not multimodal, and we couldn't get the results that we really wanted using more off-the-shelf capabilities. So we developed products for that. That said, we developed that back 15 years ago, but it stayed with us, and we are using it, and we're seeing really very good results there. We use it extensively for commercial engines, as I said, the fleet management and the fleet monitoring, although we use it for other aerospace applications as well. And currently, we're recoding this in C++, So it's a C++ base layer with Python interface to enable data scientists to pick this up and generate and add their own value to the code as well. And of course, we're integrating this with Spark, which is what Pete will tell you about in one moment. So just some examples of what Products does for us. Fleet segmentation we talked about, trying to figure out what operators and operations are happening on the engines to drive how we prioritize looking at those engines. For what Pete is doing in the fleet monitoring side, so I talked about the multivariate parameters, we need to be able to model those in a way that we can then look in a robust way what's anomalous in that data. So we take the multiple parameters off the engines, build models, and then look for anomalies there. And then we can take the outputs of those anomalies and feed them into a diagnostic reasoner, which will then give us an idea of where in the engine we might be seeing a potential area for investigation. So that's a quick overview of what we do in General Electric Aviation for commercial engines around the operational life cycle and with particular focus on fleet monitoring. I'm now going to hand over to my colleague, Dr. Peter Knight, who's going to tell you in more detail about his experiences of porting those analytics into Spark.
Thank you very much, Honor. So what I wanted to start by talking about is how have we been developing analytics in the past, over the last 10, 15 years. And as we've heard over all the keynote talks and other things, we had a collection of people doing things in a lot of different ways. Often we were pulling data perhaps from a central database into a local one. We might be using tools like MATLAB to develop our analytics and to explore the data and do plotting, as well as generating metrics on our algorithms, which we'd then have to present out to tollgate reviews to say, is this analytic adding value? Should we productionize it? And that whole process may take some amount of time and effort. But then you'd go, great, I've got a good analytic, I want to productionize it. And typically we would then have to create a whole handoff package to send over to a different silo of the organization. And we'd have to perhaps write our analytic in functional code or pseudocode or something. We'd have to send model files, send all the configuration, what engine type is this going to run on, what parameters are going to be the input, and a bunch of test cases saying, this is how it performed when we built it. Is it going to run like that in the runtime system? And then a whole other team would have to pick that up, potentially recode your algorithm into another language like Java. The configuration might be in a different format like XML instead of Excel. The deployment environment uses a different database type than our data lake uses. We have a different runtime environment which has to go through different stages of testing offline, testing in a pre-production environment with live data, and then eventually deploying to production. And so this whole pipeline thing would take ages and ages, weeks, months, to deploy something that you developed, by which time potentially the thing you were trying to solve had been fixed or was out of date. And so we're really trying to push towards getting rid of that whole myriad of tools and processes and trying to do that in Spark ML pipelines instead. So why did we pick Spark ML pipelines? Well, really we like them because we can string together all our different stages of processing when you're developing an analytic. So any cleaning algorithms, pre-processing, correction, getting rid of bad data, do your model building that might be in the middle of there somewhere, your machine learning, that kind of stuff. And then there's also usually post-processing on that, and what kind of alerting strategies do you want, that kind of thing, which you need to test your whole system. And so with ML pipelines, we can have that single set of code for doing both the development and the runtime. And obviously, it's got an extensive library of existing analytics that we can put in that, but it's also extensible, and especially using Python, which people like me as data scientists are more comfortable using. So we can use that standard API, develop new modules to plug in, and then share it with other people, and it's pretty self-describing, so other people can pick up their analytics and plug them together and build new orchestrations or pipelines to run. And you get all of that, obviously, with the Spark backend to scale to big data. So yeah, over the last few months, we've been trying to take some of both these pre-processing, so things like normalizing data, alerting. A lot of them are more complex than just doing kind of row-by-row calculations. They're doing things where you might need to group the data, sort it, do sliding windows and things like that. And so it's been a bit of a challenge getting all of that working and efficient. And then, as Anna mentioned, we've got our own custom machine learning code called Prodaps. And so one of my colleagues, Lucas Partridge, has been working on trying to convert that into Spark. And we've had success with that. We've got it working, and we've got really good performance out of it. But we've also come across quite a few challenges of using Python to develop new analytics. So we've put quite a bunch in a Spark JIRA item that's referenced at the bottom there. And some of the highlights are here. Like often with our library, once it's built, you can take that model and inference with it in lots of different ways, whereas lots of the off-the-shelf ML models kind of assume that once you've built a model, you inference it with this one way. So that's made our configuration quite complicated. Also, most of the machine learning analytics at the moment use kind of a single dense vector input, and we've found that quite difficult to work with different limitations, and so at the moment we're not using that, and there's lots of debates certainly around us whether we should or shouldn't. And also the reality of being in a big organisation is we often seem to be behind the rest of the world, so we're still on Spark 2.2, and so we can't make use yet of new things like the Pandas UDFs and also some of the ways for saving and loading custom Python stages. So we've had to write workarounds for those until we get later versions that I think support those. And one that I'd go in a bit more detail on the next slide was about setting up all your parameters for a pipeline stage. So I've got a bit of code here, which I know is very small, but I'll highlight some of the bits of interest. So this is just some example code that just implements running a straight line, so y equals mx plus c. So a pretty simple algorithm. And the code that's actually running that is the highlighted one right at the bottom of the slide, just a single line of code. And all the rest of the lines of code there are to set up passing in what your x is, what your m is, what your c is, and what your y is going to be. And so for each of those, you currently want to set up what their default value is, which at the moment you seem to have to configure in potentially 3 different places. And then you're also setting what its name is. So in different bits of the code, we've got, I think, 9 different places where you're saying what your input column variable is going to be, or something like that. And so, it's all fairly easy to do, but you end up writing quite a lot of boilerplate code. And so it would be nice if, a new feature in Spark could be like a single kind of function that you could just specify a parameter name, description, data type, its default value, whether it's a required parameter, and then potentially in just a single line you can set up all your parameters and reduce your code a lot. So there's been quite a lot of learnings, things that have worked, but things that could make life a bit easier for future developers. Another thing I want to talk about is once we're building pipelines, it's kind of useful to be able to inspect them, see what you've built is right. And you can obviously do that in code. You can print out the list of your things and loop over them and print out the config. But we certainly found it useful to also produce something that would display them. So I created just a very small plotting routine that uses Python bouquet to plot any ML pipeline. And we've now published this onto an external GitHub so people can hopefully make use of that and add to it. If it works, I'll try and show you it a bit more live. So this is a notebook that just implements a pipeline that's straight out of the docs for ML pipeline, which is just setting up some sample data, setting up 3 stages in a pipeline of a tokenizer, a transfer function, and a linear regression, logistic regression. And so you can see those stages there, and then you can fit it on the data and build a model. And if this is the actual function that displays it, so then you can use a function to say, display that pipeline, and it will show you all those stages. And if you were to hover over them, then you get all the information about it, what are the parameters and values that are set up on those different stages, so that it makes it very easy to understand what's going on, what you've set up in that file. So I'll just switch back to the presentation. So once you've done that, we can now do the whole data science pipeline that we're trying to do in a single environment, not having to switch tools all the time. I mean, at the moment, I'm still making use of a configuration file that we have for legacy analytics in order to make it consistent and be able to take things that I've already built and deploy them in Spark. And so we can take that configuration file and then use that to automatically plot things of interest that we might want to use to work out how to model the data best. So one thing we use quite a lot of is kind of a matrix heat map of data, because obviously a scatter plot doesn't give you where the density of the data is and can be quite misleading. So we make use of plots like that as you're exploring the data to decide how best to model it. And then from that, build a pipeline of what you're going to do with your data. And so our typical ones have multiple pre-processing stages like this, where you're potentially normalizing your data, where you might be correcting certain parameters, and then you're building your machine learning models, and then doing some alerting at the end. And then once you've built the model in the same pipeline, wanting to expect it, look at statistics of it, look were the clusters representing the data, did it build as expected? And obviously calculate any metrics that you need, both to understand how good your model is, but also things that we need to present to review meetings and so on, to say, will this analytic bring value? Is it catching all the events that we want to catch? Is it producing too many false alerts? That kind of thing. And yeah. So hopefully that's going to bring us towards the end of the talk. We've hopefully given you a better understanding of a bit of background about GE Aviation, and how we're really keen to use analytics across the whole commercial engine lifecycle, how we're facing this challenge of our data volume growing over time, and then some of the real-life challenges of implementing Python custom ML analytics, and giving feedback on that to the community so that hopefully they can be improved over time. And we have been able to, get that pipeline in, and, I haven't been able to do exact benchmark testing, but it's kind of looking like it's giving us 10x type improvement on the build side, as well as being able to use everything in one place. And so, yeah, and then we've also built that display utility for pipelines, which I've not seen anywhere else, so hopefully people can pick that up and make use of that. And so now we can kind of do that whole development process in a single place instead of jumping between lots of different tools. We're a long way from being done yet. We've still got quite a lot of analytics to try and move this way. And although our historic data is in a nice data lake that's using with Spark on top of it, we're still working towards getting a production side where we can use Spark to run the production data through that. So there's plenty to keep us busy to get this whole thing a nice seamless process. So so thank you very much for your time, and we can just now stop for any questions people have.
Hello. Hi, I have a slightly different question. You mentioned predicts. How efficient is predicts? And are you using, for your ML pipelines, are you using the predicts platform?
Good question. So Predix is being used for the current production system for processing the snapshot data that Honor was talking about. And so we're really trying to work, first on the building side to try and use Spark on that, and then to try and influence that production side to use Spark. So at the moment, we're not using Spark at the production side. I think Predix does support calling out to Spark, but it's not something we've used yet.
Any other questions? All right.
So aerospace has this cocaine addiction with MATLAB, and you mentioned going from MATLAB, and that was part of your previous workflow. Is it still your workflow, and how would you compare the using MATLAB as an environment to Python and its derivatives and Spark, and how is that affecting the culture within GE? Because I can't imagine that more than 10% have even heard of Python.
I can, if you like,
You can
I'll
start
start the
on.
first part. So I think within GE we've actively had a push, certainly in our part of aviation, to move from MATLAB to Python for various reasons, and I think that's been very successful. So what you said probably 18 months, 2 years ago was probably true. We probably were addicted to MATLAB. We've got off that quite quickly. And I think just by encouraging all our new analytics to be developed in Python as opposed to MATLAB, we still have a lot of legacy MATLAB that at some point we'll not have to, it works for us now. We may choose to update it or obsolesce it. But I think we have actively supported that move. So I think if we were left to its own devices, we probably would be where you say, but we have pushed that quite hard. And I think to comment on the sort of transfer, how easy it's to transfer across, I'll let you do that, Pete.
Yeah, I think I think there's obviously initial resistance to people wanting to change, and like Connor said, there's a lot of legacy stuff there, and so we haven't kind of said thou shalt not use MATLAB, and so people still use it for stuff that's already written, but we just try and encourage new stuff to be written in Python, and especially now that our data's moved into Spark and things like that, we can get a lot of benefit from doing stuff parallelly instead of being limited by our own machines and licenses and things like that. So I think there's enough pros that are allowing people to move and experiment. Yeah.
All right, great. One more.
Just out of curiosity, what's your strategy? What's your approach to actually putting Spark in production? Is more greenfield or brownfield? So, what's the strategy?
Well, I think the main thing I can say of that is that we suffer from what a lot of the keynote talks have said about organizations being siloed and stuff, and still there's a mentality that you might have your historic data in a data warehouse and build your analytics there, and then runtime should be a whole different concern, and it's trying to fuse that gap, I think, is our biggest challenge, really, to try and see that as one thing instead of two things.
But I think we know we've got to do that. And I think the problem is, as you would have seen over the talks over the last couple of days, there's a number of ways you can solve that. And for us, it's a big commitment because we have a lot of analytics, we have a lot of data, and we do rely, some people just have the data that comes in now. We do rely on our historical data to develop our models and to build up our analytics. So it's not straightforward to move from one system to another, and so yes, our target is to really get a one place to develop and deploy, or a one system, but it's probably not an overnight thing to happen, and there are a lot of decisions to be made around that, but we see the efficiencies in doing that, and that's where we want to go.
All right, thank you, everyone, and please be sure to rate the session afterwards. Thank you.
Great.